Create a toolpath simulation. After completing this video, you'll be able to simulate a single toolpath, simulate a setup, and adjust simulation settings. In Fusion 360, we want to carry on with our 3-axis sample op2. If you had any difficulty creating the toolpaths, you can upload the supplied dataset 3-axis sample ready for sim. At this point, we've been using in-process stock to validate the material removed by each toolpath. And while this is a great tool to provide instant feedback on our toolpaths, it doesn't quite have the same accuracy as simulating our toolpaths does. So the first thing that I want to do is I want to take a look at the second operation, our adaptive 2, go to Actions and select Simulate. Inside of here, you'll note that the colorization of the model is green and blue, and that we already see stock remove that happened in the first adaptive operation. We want to take a look at the different settings in simulation and what we can get out of our simulation tools. In this case, in the upper left, we have our tool display. We can toggle to show the entire tool, just the cutting flute, we can disable the tool display, or we can show the holder. It's important to note that these options are also in the dialog on the far right. We can toggle on the different display options, and in addition, we can turn on or off the programmed point and determine whether or not the tool is transparent. We also have display options for the toolpath and the stock. On the right-hand side, when we toggle on toolpath, we have a couple of extra options. We can show the links and leads, we can determine whether or not the entire toolpath is going to be displayed, or before or after the current position, just for that operation, or the tail, which happens just after the tool moves. For this example, and for most adaptive tool motions, I turned the toolpath off simply because it's a little hard to see what's happening with the stock. Next, we have our stock display, and there are a couple of different options here as well. We can display the stock as a single material, we can change its color based on operation or tool change, or we can use a comparison option. The comparison option gives us a couple of extra things that we can change as well. We can adjust the amount of leftover stock that we wish to see. So for this example, 0.02, you can see that the stock left behind by the previous operation is green, meaning we're matching that 0.02. Blue means there's more stock left, and red means we've cut below our stock. Now, in this case, the part itself is 1/2 stock, which means the outside shape is exactly the size that we need it. This means it's going to display in red if we have any value in leftover stock. We are going to leave this at 0 for our example. It's also important to note that the stock accuracy slider can be adjusted to a couple of different positions. The further to the right the slider, the longer it will take to calculate those toolpaths and show the toolpath motion. However, you will get a more accurate result. So if you're dealing with complex 3-axis machining or even multi-axis machining, increasing the accuracy can help you find potential issues in your toolpaths. But just keep in mind that it does increase the amount of time it takes to calculate. We have a viewpoint setting, which determines whether or not the tool or the model is going to move. There's a third option called machine base if you happen to use a machine during the creation of your setup. This also helps when machine simulation is running because you can see the table moving in X and Y and the spindle moving in Z, how a real vertical machine would work. In this case, we're also going to play through and allow it to remove the material. Now you can see it doesn't look like much is happening, but there are some micro cuts that are happening. And remember, we added this semi-finish operation to get a little bit smoother result to reduce the load that's going to happen on our ball end mill when we go to finish those areas. You can see that everything is still blue because even in this semi-finish operation, we left 0.02 stock behind. So everything green is matching the underlying part. Anything blue has material left on top of it. Let's go ahead and exit the simulation, and this time let's select the entire op2. I'm going to go to Actions and Simulate one more time. This time, because we have multiple operations, I want to note at the bottom that we have these segmented areas. This will tell us when we have a tool or operation change. These areas will display in red if there is a collision with any of the non-cutting portion of the tool or the holder. Also note that we can click at any point in this timeline and move the tool to that position and calculate the stock. We can also hold down the left mouse button anywhere in the canvas area and drag it to the right to play forward or drag it to the left to play back. This can be helpful if you get to a specific point in a toolpath and you want to evaluate the way that a tool is moving. I'm going to jump ahead a few operations, and in this case I'm going to jump past our first scallop operation to show how long the calculations take even though we're not playing through the simulation. This is because we have a very fine step over amount or a very low cusp setting when we're using our scallop toolpath. Once again, this is important because there's a difference between this stock and the stock we saw in in-process stock preview. The stock here does not show any cusps or any potential issues with the surface. So this means basing our step over or our cusp height solely on our in-process stock means that we can likely be increasing our toolpaths artificially. As we jump ahead to the next operation, once again, we can see that it's taking a good bit of time to calculate, and that's because, again, we have a very small step over amount. Doing this for a single operation can be helpful, but remember that when you come in the middle of your toolpaths, this means that you're going to be using in-process stock for all previous setups. Let's go ahead and just simply jump to the next operation, which is going to clear off this fillet over here. This is our last scallop toolpath. We can already tell, this being our last toolpath, that we have material left behind on this wall, as well as at the base of this dome. There are a couple reasons for this, but we need to evaluate our model to find out the actual cause. First, let's exit the simulation, and let's go to our 3D toolpaths and select 3D flat. I want to create a 3D flat toolpath using my tool number 5, our 1/4 inch flat end mill, and I want it to evaluate the model and figure out where it can machine. Underneath the passes, we're going to be using the pocket strategy. The step over amount is going to be relatively small. I don't want to use 1/4 inch because that's the size of the tool. I'm going to allow it to step over a distance of 0.1. There are a couple of other options here. I'm going to allow it to machine over holes. Even though we don't necessarily have any holes in this model, it could potentially consider this bowl as a hole, and we want to include a single finishing pass. My finishing step over is going to be relatively small. I know that we already left 0.02 on the side of our model, so I'm going to make that finishing step over a small amount. Here we have our max hole size. In this case, I'm going to increase this to 1.5 inches, and then I'm going to say OK. This toolpath is going to go through and calculate the areas where it needs to machine. You'll notice that it added toolpaths to the top of our part as well as the sides here. Now these areas have been finished, and it's a good idea for us to do this flat operation directly after our semi-finish. So holding down the left mouse button, I'm going to drag it up inside of my browser to put it after our semi-finish. This means that we will need to recalculate some of these operations. You can see that it happens automatically, and you'll notice that this flat toolpath is still machining in the same areas. However, this means that other toolpaths such as scallop or spiral toolpaths may not need to machine quite as much. When we take a look at this as our option, we might want to go back and edit some of the other toolpaths to increase their efficiency. For example, there's no reason the scallop toolpath now needs to machine these faces. We can go back into that toolpath, select Edit, go to our Void Touch Surfaces, and we can remove these flat sections and recalculate our toolpath. When we do that, we can see that we are still machining the entire area. It is rolling over the corner like we expected, but we're not wasting time trying to machine these flats, which is not an efficient use of a ball end mill. This scallop is okay because there were no flats that we were machining, and this last operation is also okay because there's not really much of a flat area, but we could remove that from our selection as well. As we take a look at this model, we can see that there are issues with this fillet, that material is still left behind. Now, the potential cause for this could be a geometry issue, or it could potentially be a tool issue. I'm going to move over to the design workspace. I'm going to select that fillet, find it in the timeline with the 3 small lines above, and edit the feature. We can see here that the radius of this fillet is 0.06. Now, it's smaller than the tool that we're trying to use to clean it. This means that we either need to use a smaller tool to get into that area, or we need to increase this fillet if that's an option on our design. I'm going to increase this to 0.08 and OK this to update our model. Now keep in mind, when we do this and we go back to the manufacturer workspace, all of our toolpaths are now going to be out of date. Now 3D toolpaths are going to be model aware, which means that we need to recalculate everything. I'm going to select the Setups folder, go to Actions, and Generate. Generate will recalculate the toolpaths, it'll recalculate the parameters, and ultimately the in-process stock. As this is happening, you can see a blue circle that swirls around as it's calculating. You can see a green check mark with a dash on the outside, meaning that the toolpath is calculated, however the in-process stock is not complete. Part of the reason for that is because a lot of these operations are going to use rest machining. When we're using rest machining, in-process stock needs to be calculated for the first operation before it moves on to the next. So until this 3D adaptive is finished calculating, the in-process stock won't be able to update. You can see that the operations in Op2 are just now starting to calculate. Ones that didn't necessarily require the previous operations were calculated quickly. This is because things like our flat toolpaths or our scallop, we selected specific faces and they weren't necessarily looking at stock that was previously removed. This means that they can calculate much quicker. Now let's go ahead and take a look at this operation, and you can see at the very end we still haven't machined that area. There are a couple of toolpaths that we could use to clean this out. This is something that we do want to make sure that we explore and understand. For this example, let's take a quick look at our pencil toolpath and see how we can use this. We're going to continue to use our 1/4-inch ball, and under geometry, I'm going to select a specific area. In this case, I want to select the outside bounds of that fillet, and I want to contain the tool in this area. In our passes section, notice that we have a number of stepovers. I'm going to add 5 stepovers, which is likely more than we need, and the bitangency angle is going to determine the amount of contact that the tool has with that fillet. Now, because this is not a complete 90-degree corner, we don't necessarily have 90 degrees of contact, but 20 degrees of contact is not going to be enough for us to clear this out. So I'm going to increase this to 35 degrees and just validate the results. When we take a look at the results, you'll note that no toolpath was created. Part of the problem could be our bitangency angle, and part of the problem could be our stepover amounts. I'm going to use a 0.01 stepover with 5 steps and say OK and allow it to regenerate. Once again, you can see that this toolpath is still causing a warning. Let's go back and let's validate our bitangency angle. If we set this back to 20 degrees, which is a very small contact on the tool, and regenerate, once more, you can see that it's still not able to validate that. If you run into this issue, sometimes what you can do is go back to your geometry selection and simply use a silhouette of the part rather than a selected area. When we say OK, you can see now it's generating the toolpath. It is trying to make a cut over here, which doesn't make a whole lot of sense, so we do want to make sure that we contain the tool. I'm going to hit F7 to hide our toolpath, and now we can see that the preview looks a bit better. We might want to increase the number of stepovers, ensuring that we machine everything. So let's make one last adjustment to this toolpath. Let's go into our passes and let's increase this to 8 steps and OK. Once more, it's going to regenerate and allow us to see it in in-process stock. But we should validate this through simulation. Remember that when we're simulating based on in-process stock, that the resolution of the stock calculated is going to be much lower than if we ran it in simulation. We can see that inside of the bowl feature and on the outside of our rib feature. Since that's not really critical for what we're inspecting here, let's go ahead and slow the simulation down and let's play through. So once again, you can see it's trying to cut that wall. What we could do is we could select avoid for that wall to keep the tool away from there. And then ultimately what we want to do is we want to evaluate its cutting of that fillet geometry. So as it moves back and forth, you can see that we are wasting a little bit of motion because it's trying to cut a small portion of that floor. As it moves its way around, we can toggle on our tool paths and we can see where the tool is moving. I'm going to change this to tail so we can see just where the tool was, and I'm going to turn off the points, which will increase the display. So as the tool goes through, you can see that it is removing material. It's smoothing that fillet out, but we're still not getting all the way into the root of the problem. This takes a little bit more exploration, and oftentimes these small details are where it's going to be difficult for you to get all the material removed. One of the best options here is likely to use a smaller ball end mill to come back and clean that up. But I want to leave it at this because this is a great area to explore, and I think coming back in a challenge or a practice exercise will help us explore the toolpath a little bit more. At this point, make sure any changes are saved before moving on to the next step.